We have all heard the phrase, "one small step for man, one giant leap for mankind." Neil Armstrong uttered these famous words when he became the first human to set foot on the moon. Today, NASA is on the verge of another giant leap, this time in the realm of timekeeping. They are developing a lunar time zone. This is not just a simple adjustment of hours, but a whole new way to measure time on the moon. Why is this important? Because time on the moon doesn't behave the same way it does on Earth. It's all thanks to a brilliant physicist named Albert Einstein and his groundbreaking theory of relativity. Einstein showed us that time is not absolute. Time can be influenced by gravity. The moon, with its weaker gravity, experiences time slightly faster than Earth. It's a tiny difference, just a few microseconds per day. However, these microseconds add up. Over time, this discrepancy could cause major problems for future lunar missions, especially as we establish permanent bases and conduct complex scientific experiments. Imagine a future where we have lunar rovers exploring craters, scientists conducting experiments, and maybe even lunar residents going about their daily lives. Accurate timekeeping is essential for all these activities. To understand why we need a lunar time zone, we need to grasp the fundamental concept of relativity. Einstein revolutionized our understanding of time and space. One of his key insights was that gravity affects time. The stronger the gravitational pull, the slower time flows. Earth, being a much larger celestial body than the moon, has stronger gravity. This means time actually moves slightly slower on Earth compared to the moon. You might be thinking, it's just a tiny difference, does it really matter? For our everyday lives on Earth, not really. But on the moon, where we aim to establish a permanent human presence, this time difference has significant implications. Imagine trying to coordinate a lunar landing while your clocks are out of sync, or conducting a scientific experiment where precise timing is crucial. The time difference could lead to errors, miscommunications, and even safety risks. So, how do we keep time on the moon? NASA is working on a solution. They plan to establish a dedicated lunar time scale. This new system will take into account the moon's unique gravitational environment and ensure accurate timekeeping for all lunar inhabitants and missions. Currently, timekeeping on Earth relies on atomic clocks. These incredibly precise timekeepers use the vibrations of atoms to measure time. They are the most accurate clocks ever built. The data from these atomic clocks is used to establish Coordinated Universal Time, UTC, the primary time standard by which the world regulates clocks and time. In space, things get a bit more complex. The International Space Station, ISS, for example, relies on atomic clocks both on board and on Earth. These clocks are constantly synchronized to maintain accurate timekeeping for the astronauts. For the moon, NASA is considering several options for lunar clocks. Atomic clocks offer the highest level of precision but are bulky and expensive. Crystal oscillators, on the other hand, are smaller and more affordable but less accurate. A combination of both technologies might be the best solution for lunar timekeeping. The development of a lunar time zone is not just a technical challenge, it's also an international endeavor. Just like we have international agreements for time zones on Earth, we need a global consensus on lunar time. This is crucial to ensure compatibility between different lunar missions and future lunar settlements. The lunar time zone is just the beginning. As we venture further into our solar system, we will encounter similar challenges on other celestial bodies. Mars, with its own unique gravitational pull, will also require its own timescale. The work NASA is doing today to establish a lunar time zone will pave the way for future interplanetary timekeeping. It's a testament to human ingenuity and our relentless pursuit of exploration. As we set our sights on the stars, one thing is certain: time will always be of the essence in the grand cosmic dance.